Hello, today we're continuing our work in algebra and we are looking at logarithms, which are usually abbreviated when we speak to logs. And logs or logarithms are just ways of doing maths more directly with the powers of numbers. So we know about powers and indices, and we know that it can be a nuisance to have variables up in the powers of numbers. So if we have base a to the power x. So we have a number which we call the base to the power x is equal to y. That would be the same as log to the base a of y is equal to x. What's the difference? The power is now written down as a separate number. So if we're dealing with a log, we're dealing with a power. X in this case is a power on a number. It's a power on a, but by writing it in log notation, we're able to do maths directly with powers. And there's a bunch of funny rules that come along with using logs, and you can see very directly that they're just the rules of indices, the rules of powers that we already know. I have them listed down here. They're on page 21 in your log tables, and this is another very important point in terms of the exams and logs. The second I see anything to do with logs, or later on we'll see LN as an abbreviation for a particular type of log, the second I see that, I'm going to instantly open up page 21 in my log tables. It doesn't matter how simple the question looks, 21 in my log tables, always open. If I take a quick look here, I'm claiming that logs are ways of doing maths with powers. So if I look at my original power rule, I have a to the power of p multiplied by a to the power of q is equal to a to the power of p plus q. If I look at the first rule in logs, I have a log of a of x multiplied by y is equal to log to the base a of x plus log to the base a of y. Can we see the connection? We had our two numbers multiplied together. And that resulted in us adding the powers. The logs are the powers. So we are adding the powers when we were multiplying our original numbers. So that is the core concept of logs. We are dealing directly with the powers of numbers, and all of the funny rules that we are going to deal with on page 21 in our log tables, you can look across. If we were dividing numbers, we subtracted their powers. If we're dividing the numbers inside the logs, we end up subtracting the logs. If we have a power on our original number, if we have a power on the bracket, we end up multiplying our powers here. So we had a power on x, and it ends up multiplying by the power here, the log of log to the base a of x. And likewise, a to the power of 0 is equal to 1. A to the power of 0 is equal to 1. So 0 is the power. So log of 1 is always going to be equal to 0, regardless of the base, because any number to the power of 0 is always going to give us 1. So if we can get ourselves to the point where we're happy with the idea that logs are just the powers of numbers written in a funny looking form, life becomes a little bit easier to keep track of. So if I put this in a number example, I have 2 to the power of 3 would be equal to 8. If I want to write that in log notation, I would have log to the base 2. Remember, we often called this a base number, and this was our power. So the base 2 of 8 means what power of 2 is 8? And it's 3. So what power of 2 gives 8? And it would be 3. Now, that's one way of solving that. You can look at your base and you can see that this automatically is going to be 3. So log to the base 3 of 27. Well, 3 to the power of what gives 27? Hopefully we're all happy that that is going to be 3. But for more complicated answers, there is a method that we can use to try and rearrange this a little bit. And that's to use the definition of logs that we've got up here. So I'm saying that 3 to the power of something, x, is going to equal 27. So I have 3 to the power of x is equal to 27. And now we're back to an indices problem like we were dealing with earlier. So I try to write this as a power of 3. We're going to look very soon at another way of solving this problem, which will work more generally, where you can't write this as 3 to the power of x is equal to 3 to some nice power, because you won't always get numbers that will be the cube of the number you're looking for, or to the power of 4 or 3 or whatever. So we need to have a more general method. But for right now, for getting comfortable with the idea of logs, being able to switch between these two ways of writing it is important. So that's what we're going to do for the early questions. But there is another more general method coming soon. So if 3 to the power of x is equal to 3 to the power of 3, x must be equal to 3. Now this can get a little bit messier. If I wanted to know the value of 3 log to the base 2 of the square root of 8, I would set that equal to x. Just to be clear, I'm going to talk to you by the end of this video about how you can put this into your calculator directly and find the answer, but they can ask you, and have asked on the exam, to do this without a calculator. So if you just write down a calculator answer, you don't get any marks. So we have to be able to do this without the calculator. Now I know that the square root, to begin with, square root here, log base 2, I have square root here. I know that as a power is going to be power of a half. So that's one bit of simplification I can just do right out the gate. But I can see here that I have my power, the log part, is multiplied by 3. Well, what does that mean? It means that the number in here would have a power of 3. That is the reverse of my third rule down here. So that means that I can simplify this to log to the base 2 of 8 power of a half cubed is equal to x. Now I have this as just a log equals x. I can use my definition of logs. I'd have 2 to the power of x is equal to this business. So 2 to the power of x is equal to this stuff here. It's important you are able to rearrange in this way, because they can ask questions and have asked questions directly based upon being able to do this. I know that if I have a power on the bracket, it means that I'm going to multiply the powers, so I'll end up with 8 to the 3 over 2. I know that I can write 8 as a power of 2. So it's going to be 2 to the power of 3 to the power of 3 over 2. 2 to the x is equal to 2 to the 9 over 2. Now I know that I can equate and say that x must be equal to 9 over 2. Again, because 2 to the power of x must equal 2 to the power of 9 over 2, there's only one value of x that would make that equality true, and that's if x was equal to 9 over 2. So that's the most basic version of these type of problems, and it's essentially just getting stuff into the form where the log is by itself is equal to x, and then you are going to rearrange this into 2 to the power of x is equal to whatever is in the brackets here, using the fundamental definition of logs. Now, other types of log questions here might ask you to solve this type of problem without using a calculator. So now we're going to be going to page 21 and using some of the other definitions of logs here. So I can see that if I'm adding logs together, it means the numbers in the brackets would be multiplied. And if I'm subtracting them, it means that they would be divided. So let's see if we can do that. I'm going to deal with my subtraction first. So I end up with log to the base 6 of 9 is equal to log to the base, sorry, not equal to, plus log to the base 6 of 8 over 2. How did this come about? Because I had 8 and log to the base 6 of 8 minus log to the base 6 of 2. So I ended up using this rule in reverse. If I'm subtracting the powers, it means I was dividing. Same rule as what we had for indices. So if I work that out, I get log to the base 6 of 9 plus log to the base 6 of 4. And I'm adding logs, which means I'm multiplying my original numbers using my first rule of logs. So I have 9 multiplied by 4 in my brackets. So I get log 6 of 36. And now I can recognize that I can use my rules of log. 6 to the x is equal to 36. 6 to the x is equal to 6 squared. X is equal to 2. So the last little bit that I want to touch on is more for you to work along as I'm doing them. If you use log on your calculator, it is secretly log to the base 10, or rather it defaults to being log to the base 10. So the log button on your calculator is really log to the base 10. And if you put that into your calculator, you should find that it's approximately equal to, these should actually all be wavy equal signs because I'm only giving approximate answers, 0.4771. If you get log to the base e, which would be another button on your calculator, which might be called ln, the natural logarithm. We will come back to this natural logarithm later, but for right now, log to the base e is called ln, the natural logarithm. And that is asking the question, the number e, the exponential to the power of what gives 3, and it is approximately equal to 1.0986. And if I wanted to put something into a novel base, so novel base means an unusual base, so not log or log to the base e, which I'd have buttons for on my calculator, but a funny base like to the base 7 or the base 6 like I had here, what would that give me? Well, I need to use a button on my calculator, which is usually on the top right, but varies from calculator type to calculator type. On the Casios, it's usually up at the top right. So log with a little box and then a big box. And what we're going to use is the arrow keys. We're going to start out in the little box and put in our base, and then use the arrow key to move over and fill in our big box for our main number, the number in brackets. So we do this button on our calculator, and then type in 3 and then arrow, type in 7, I should say. Type in the base first. Type in 7 arrow, side arrow on our calculator, or 3, and then equals, and we should get 0.5646. So you need to be able to use your calculator with logs for certain types of problems, and if they ask you to graph logs, as they could. And we will return to this later, but I will mention it in passing now. It may be obvious to you from the way that these are written, but logs and exponentials are inverses of each other. They are inverse functions. They undo each other. And we will return to that in more detail later, but I'm going to mention it now so it's in the back of your minds. And that's actually how we're going to solve these types of equations later on. But for right now, we have the definition of logs, which is on page 21. The actual definition, fundamental definition of logs, if you get stuck on the exam, is at the top right-hand corner of page 21 in your log tables. So we always have the definition of logs and all of the rules that we need for both logs and powers, everything you need in the exam for rearranging these formula on one page, page 21 in your log tables. So the second we see logs in our exam papers, page 21 gets opened up. And other than that, we can see how we use those rules to simplify our equations, and we must be able to do our calculator work with logs as well.